Bhaskar garu to occupy the dais. DSR Shankar garu to hand over the okay. I request here DSR Shankar garu to hand over the bouquet. Now I welcome Secretary S. Durga Prasad garu to occupy the dais. We have Sunit to hand over the bouquet. Now I welcome Treasurer here Nallam Bhaskar garu to occupy the dais. Here MNR Chandrasekhar garu to hand over the bouquet. Secretary garu to hand over the bouquet. Now I welcome here SPM Chandrasekhar Rao garu, MC member to occupy the dais. Here S. Rambabu garu to hand over the bouquet. Now I welcome Senior Manager Sheikh Sriram garu, Accei Industries to occupy the dais. Here TV Srinivas garu to hand over the bouquet. Now I welcome today's program chief guest Dr. Ram Prakash garu to occupy the dais. Now I invite Secretary here Durga Prasad garu to hand over the note. Thank you.
Thank you, Prasad garu, for your wonderful welcome address. Now, I request the chair to light the lamp and start the session, inaugural session. I invite all the members to join for the lighting of the lamp. రండి సార్, అందరూ రండి, ముందుకు రండి, అవకాశం చూద్దాం. రండి సార్. రాముగా రండి.
సార్ కొంచెం దగ్గరికి వచ్చేద్దాం దీపం. సార్ చాలా క్లోజ్గా వచ్చాను సార్ దగ్గరికి దీపం దగ్గరికి. సార్
షేర్ చేస్తున్నాను. మూర్తి గారికి మాది రండి సార్. రాంబాబు గారు రండి సార్ షేర్ చేయండి.
సార్
సార్ రండి సార్.
సార్ 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 కొంచెం దగ్గరికి నుంచండి సార్ అందరూ ఒకసారి కొంచెం దగ్గర క్లోజ్గా కొంచెం అందరూ
రండి
సార్ వేణుగారు
మేడం రండి
రండి.
ఓకే రెడీ సార్ స్మైల్ ప్లీజ్.
I welcome Professor Subbarao garu, please on the dais. Please sir. I request Chairman Balasundara garu to say a few words about today's session.
today is a part of our regular commitment. Every month we promise to have either one seminar or webinar. Till now, since inception, we never failed. Even in Corona also, we made it very successfully. This program is part of that thing, and it's a very memorable day. Why? Because a great personality, Dr. N. Ram Prakash, is with us here. Actually, you know, he is of about 78 years age. At this age, he is kind enough to come out to Kakinada and to interact with us, and he wants to share his experience and expertise in the field of not only structural engineering, in project management and in quality control also. He is an all-rounder in civil engineering, and we are lucky to have him here on this day. I am highly thankful to him, sir. Thank you, sir. While coming from Madhurpudi airport to Kakinada, we got good interaction, and what I thought is that we have to learn so many things from him. So it's an opportunity to us within this 2.5 hours time. Whatever we can extract from him, we will extract and we will learn. Thank you very much, and I thank all of you for attending this very seminar. Thank you.
Thank you, sir. It's a great day for us. Accei Kakinada need to celebrate great personality. Dr. Ram Prakash is here with us to share all of his knowledge. All happening because of management committee's teamwork, member support. Being a knowledge trustee, members came from here, crossing the rainy weather. Few of members came from far places like Tuni and Yanam. Unfortunately, Amlapuram team not came here due to heavy rain. Members given us lot of flexibility for doing the huge number of technical activities. Coming to today's event, Emerald project of Dr. Ram Prakash will give us brief of the prestigious projects done and challenges faced by Dr. Ram Prakash. Mrs. Kartikeya Industries Private Limited came forward and supported this event. Sri Ram, Senior Manager Sales, Adish Pramod, Senior Engineer Sales, Ramesh B, given a lot of support in this program organization. Finally, we got this opportunity to interact with the expert speaker. Further, an announcement of our ACCA center elections as well, state center elections as well as national body elections. As you all aware that headquarters has announced the election schedule for the year 2023-25. As per that schedule, nominations are to be submitted by courier, post, email or on or before 28th of this month before 5:30 p.m. Dr. B. Krishna Rao is our returning officer. Date of nominations withdrawal is April 3rd, this year, and date for voting is 20th to 25th of April, that is next month, before 5:30 p.m. Declaration of results on 26th April by 10 a.m. The protocol is Chairman, Secretary, Treasurer and 4 MC members. Interested candidates may download the form from ACA website and make the elections process grand success. Now I welcome our Treasurer say a few words about the program. Welcome, Bhaskar Garu.
Good morning all. Today we are meeting again. Every month we are conducting some programs, technical programs by our chairman, Madhav Sundar Rao garu. Under his guidance, we are working to Kakinada Center. ACCA Bangalore, founder member, eminent person from Bangalore, beloved and Ram Prakash garu here. For us today he came all the way from Bangalore and he is delivering his wonderful speech. We are waiting for that. Thank you sir for attending our college. It is a great pleasure to us to meet you personally and interact with you, sir. Thank you very much.
Now I request Chandrasekhar garu to say a few words.
Good morning, all of you. It is very pleasurable to meet all of you here. This is one of the most important technical session conducting. Our chairman, secretary, and all the members are taking so much efforts and putting so much valuable time to enlighten all the engineering community in general. Unfortunately, so many students are missing maybe today and due to some other engagements and all. But we are very fortunate to have Dr. Ram Prakash garu here, the legends and stalwarts of the civil engineering community. Every time we are hearing about Engineers Day, Mokshagundu Visvesvaraya, and we know very few legends in the civil engineering community. So we are trying to understand what is going on after Mokshagundu Visvesvaraya, and so many prominent engineers are making it proud to be a civil engineer, and he is one of the most prominent engineers, civil engineers in India, and he did so many first time in India, first time in Asia, and first of kind, the inventions and application, execution and all. It is very difficult for us to know their experiences by going in different places like Bangalore and all. He took a lot of time to deliver his speech here. Let us all make use of it and benefit with his experiences and be proud of him. Thank you.
Thank you, sir. Now I request Sriram from Karthikeya Industries to say a few words about the program.
Good morning to all. We would like to say thanks to respected ACC members of Kakinada region and our beloved chief guest, Dr. N. Ram Prakash ji, to give us this opportunity to present about ourselves at this occasion. So myself, Mr. Sriram Karedla, and I am Senior Manager Sales and Marketing from Accei Industries, Hyderabad. Today it's my pleasure to be here with you all along with my colleagues, Mr. Aditya, and he is a Senior Engineer in Sales and Marketing, and he is looking after sales net marketing activities AP region. And Mr. Ramesh, he is from Hyderabad and he is looking after digital marketing activities. So first time we are presenting in a conference like ACCA in Andhra, and I hope this presentation will give us more mind to us to go into market and get to meet more people in the market. So thank you for this opportunity once again, and thanks all.
Thank you, sir. Now the time for technical session. before going to the presentation, a small video made by us regarding our activities done from the starting of our center.
Front light ला light ला
all because of our ACCA members support. We have done good amount of activities during this period. Total months, it is about 32 months. We have conducted about 27 webinars, direct events 7. We have done 6 field visits, student activities 4. Thank you one and all. Thank you very much. Now I request SVM Chandrasekhar Garu to introduce our today's chief guest.
I feel it is my privilege to introduce today's chief guest, Dr. N. Ramprakash Garu. In fact, it is very difficult to introduce within a stipulated time. The legendary personalities like Ramprakash Garu, I am very fortunate. He is a graduate of civil engineering from Bangalore University in 1967 with advanced pre-structured concrete as elective. He did his PhD in civil and structural engineering from Indian Institute of Science, Bangalore in 1973. Researched on torsion and combined torsion in reinforced concrete. He published many papers in national and international journals like American Concrete Institute, International Association of Bridges and Structural Engineers, and so on and so forth. And professionally, as professional institutions experiences, he worked as past president of the Association of Consulting Civil Engineers India, is a national president, and former vice president of Indian Concrete Institute, and past secretary of the International Association of Shells and Spatial Structures Indian chapter, and founder member of the past president of the Institution for Research and Development and Training Construction Trades and Management, INSTRUCT. Currently governing council member of Structural Engineers World Congress, a subsidiary of SCWC, former chairman of TechMag Consultants Private Limited of India, consultancy organization of infrastructure and heavy industry, former advisor of and specialist to Total Outsource Inc. Chicago, USA. Former acting chairman of and director of Mrs. National Cooperative Bank Limited, a cooperative bank with 3,000 crores turnover. In fact, he is a multifaceted expertise. His expertise in design, detailing, construction management and project management of steel structures, concrete structures, pre-structured concrete structures, unconventional structures and buildings. Proof checking of computer analysis, design and detailing, technical audit, quality audit and quality systems consultant, project management consultancy, project leadership, so on and so forth. Some of the important projects during his professional career are the first to design and manage the construction of the first apartment building, Ravikiran Apartments in Bangalore in 1980. As a total project construction and project manager. By that time, construction management also very few people know about it. By that time, he is a first to design and manage the construction. Said to be the first in India, and some said maybe the worldwide also, to design and get constructed 2 large multiple barrel cylindrical shells with feather edge beams for Mrs. Fat Alve, Kerala, for a treatment plant and another BHEL executive dining hall in Bangalore. Said to be the first to incorporate and get constructed large stores complex using extensively precast funicular shell modules, which ostensibly saved 11% cost to BHEL in Bangalore. Not only strength and stability, cost saving is also one of the major role and major duties of a civil engineer. 11% of a major project is not a joke. Set to be the first in India to do the highest level conical water tank with no scaffolding from ground with outrigger beamforms. Designed 88-meter diameter tubular double layer grid lamella geodesic dome for the coal stacker reclaimer building of the cement plant near Bangalore, which is the first of its kind in Asia. For that, he entered into the Limca Book of Records also in 1994. See it extends. His list of successful projects goes on endlessly, and the time is not permitting. Dr. N. Ramprakash Garu's name also has been appeared in the Limca Book of Records in 1994 for this lamella grid dome structure. That is a high strength, using high strength tubes, first of its kind in Asia. Dr. Ramprakash Garu also recently awarded the title of Eminent Concrete Engineer of Karnataka in 2016 by Indian Concrete Institute, among other recognitions and awards. Thank you so much, sir.
Thank you, Chandrasekhar. Now, I request Dr. N. Ramprakash to deliver his valuable lecture. Welcome, sir.
Hello everybody. Good morning to all of you. At the outset, I am carried away by this Kakinada Center. Actually, I am one of the founders of this ACCE, and I never can just imagine in 1985 when we formed this association that we will have such luminary centers all over India, consisting of a lot of people who are luminaries. So first I'd like to pay a salute to whoever coined this center and merged it with ACC. Welcome to ACC. And word about how ACC was formed for those of you is that there was a Gangaram building collapse which happened in '83 in Bangalore. And 9 of us, we joined together and we said, most of the time, I feel all of you should also do that when there is a failure, you should make your own investigation. 3, 4 people, 5 people just get together and say, it's not to find fault with what has been done. Don't find fault with that. Take lessons from what has happened. Come back and share it with everybody. Because it is not a question of one being superior or inferior, but the whole fraternity getting a bad name. For example, if there is a failure somewhere regarding Bhuj or something, would you believe that in Boston, in the public TV, they are showing why it has failed, what is the fellows, what they have done, what is wrong with it, and things like that, and then say Indian civil engineers can't do well, so we have to go to India and do work. This is not it. Who are the people who are doing the jobs in USA? It is the Indians who are doing the jobs there. Our own people are doing all the designs there. They are there because they are heard. They are given jobs and they are given respect, and whatever they deserve, they get. So that's just a background to that. I was the first secretary of ACC, then after that president and whatever. Forget about all of that. We are all a family, okay? I'm very happy that, to be amidst all of you people. And don't think I'm doing any marketing. I don't like this marketing thing. I don't say, I don't want to, this lecture is not to do any marketing. This is only to inspire some of you in the different subjects. There is steel, there is shells, there is space structure, there are so many things. I give you all my experiences because I have gone through the mill day in and day out. When I say funicular cell, the fellow wouldn't know how to spell it. But I have to get it into the project. And who are my clients? BHGL. Who are the civil engineers, senior people there. I shouldn't lose patience. I teach them what is funicular shell. Then everybody says, huh? One person says, I saw it in SCRC. Is this the one? They were doing research. You know, things like that. You have to, I mean, it's human. So I start there and then we do that. Then the people will say, fall, will it stand? Is it economical? But you had better do your homework before. For anything that you want to do tomorrow, you should know 200% today, not 100%. Because your delivery is only 50%. Efficiency is only 50%. So you've got to know all that. So I knew everything about funicular cell because I had gone there and I said, I attended seminars in IT Madras, SCRC and all that. Then they go and see what research is going on. So that's how it happened. And so this is not to say that I'm trying to portray myself. I'm just trying to tell all of you that what all we can do, what all, if I can do it, all of you can do it. That's what I feel. So I will tell you what it is. Now, okay, now I'll start with this. This is a collage of some of the projects that you should know. See, a person like me could get into all of these projects. So first of all, I'll be covering all these later. But first of all, you see there are shell roofs there. Okay, these are shell roofs. This is a space structure. This is a pre-stressed roof for a double basement, 85 feet span, 75 feet span and things like that. Of course, a lot of nuances are there, and we will come to that after. This is the powerhouse that I did for Alberti Dam people. This is an industrial building with high, heavy-duty racks, 8 meter high, 10 meter high, etc. for an MNC company. Because this is a factory for Jyoti Laboratories. They had built 5 factories before, and they came to me that I had to just repeat one of those factories in Bangalore. I told them I don't repeat. I will be starting from scratch as though I have not seen any of your 5 buildings, and then I will do it. And I did this job, and later it was told by the chairman that I have done it to international standard. But come to that, imagine how much work I might have done, you know. So put it all that all of you have to do work, and there is a saying, if you want me to tell you, that in the 21st century, to be where you are, you have to keep running. You know, to be where you are itself, you have to keep running, let alone taking forward. Okay, I will just run through my program a little fast because I have to cover a lot of subjects. So whoever is having anything to say, we'll say it in the end. You can ask me any question. As was told, I would like to thank the chairman and secretary, the committee members for putting together all of you for this particular thing, and I hope it will be useful for all of you. Okay, I start with, I was a bachelor's in 67, and my passion was precious concrete. I wanted to do only precious concrete. I was really wanting to go places because I had done some bridges and things like that. So I was very much interested. Then I joined Indian Institute of Science in 68, came out in 73, and I wanted to do it pre-stress. But it so happened that the reinforced concrete thing that they had done, I had a lot of things to say about it. It had to be changed. So I changed it, and so I went back to reinforced concrete then. Then I did this research on total torsion and combined torsion IS 456. This whole thing is there, all because of Dr. Vishwesharaya. You know, people wanted to copy German code, people wanted to copy the American code. In the committee, there were 4 people who were from Europe, PhDs or something, and 3 people from US. So the majority would put the German code in the Indian code. And here we are given a recommendation. Somebody talked loosely about our recommendation. saying that will it work? I don't know who these people are and all. And my professor got wild. He told Dr. Vishwashraya, you have to listen to us before you finalize. Listen and then say we are copying or we are not fucking. When we made the presentation, Dr. Vishwashraya said, you are the people who should tell us what we should do in Tosh. You know, such great people, eminent people are there still in this country who will support you. So it happened, and we told them exactly what is the thing in Tosh, and we are up to international levels in whatever we were thinking, and we got that goal. Then immediately, another thing is, I started consultants in India immediately after PhD. You know, as all of you know, immediately after PhD you get raw offers. Okay, I got offers in this, I'll tell you about that later. Then I had multitude of anecdotes and hurdles circumventing thereof. You must have a lot of patience when you do something new. You'll hear a lot of things. People will ask you where it has been done, is it safe, is it this, is it that, and finally they say, hold to it. I'll tell you about that also. Would also like to place a record the contributions of, I think you have to make it a little smaller, contributions of all the people who worked in my office. You know, people who came to my office, they're all human beings, right? Then some of them are Bs, some of them are Ms and things like that. I used to tell them, you think about the subject and think about the problem. Don't just take words from my mouth and do it. You think. So all of them I used to make them, now what will you do if you are asked to do this project? So they would be, by that they would be getting respect. And also their brains would be working. Not that they're just following, putting it onto the, what shall we say, software and getting out the solution. They will come out with something. Then I would say, don't you think this is not the right thing to do? Why not this, why not that? And the total teamwork has helped me a lot to do. Okay? Okay, then this is the background to all what I did. And so I found that most of the research, you know, in India was useful for US or UK to change the US code or UK code or something of that kind. They would refer to Indian research and all that. And all the people who are working in IISc, I hear that one person is here from IISc. I am not boasting about IISc. Every organization, even JNTU, every organization is great. It's only you have to see who is doing it, what he is doing, and recognize that greatness. Okay? So here, it's all being implemented abroad. In fact, one person went from civil department for a conference in US and made a presentation. There, one of the senior directors of IISc also attended in aeronautics. He didn't know this person was working on the same subject with the same organization. Same Indian Institute of Science, he was working in civil department on dynamics, random vibration. And he learned, Joga Rao, he's a senior director of IISc. He went to the aeronautics conference and found Narayana talking about random vibration, and he's from IISc. Next morning when he came back from US, he was standing at the door of Narayana waiting for him to come. He said, this is bad. I'm going to break this. Guys, within this campus, ourselves are not integrating. So that's one of the things about IISc and all that. Now don't say that people don't do PhD or theoretical and this or that. Don't tell me that. At least tell anybody else, because all we guys want to know more and more of less and less. If you want to know what is PhD, but you will be optimizing, you will be making it pakka, you will say the last word on that. Okay, it's not a post, just like that. So immediately I was offered jobs. Okay, I started practice to improve implementation in India. So just when I came out for 5 years when I was doing my PhD, because I got a direct doctorate, the master's I registered for, but the work was high for masters and low for PhD, so I asked to work a little more with the direct doctorate. That's another story. But I mean, that's one of those. My interest was so many other things. So I wanted to see that the outside when I come, all the building, they're going on doing, I was telling Mr. Sundarrao yesterday, that people were doing direct load analysis. Just direct load, people from Bombay used to come to Bangalore and do multi-story building in I have done the first apartment there, but these guys used to come and take up the jobs, and they were like 25%, 30%, 40% like that in the cost of the project. And Accei, the general manager, told me very jokingly when the building was opened, he said, "You have saved me so much, I can put up a car park free of cost now." Things like that. So it was resulted that VHL was my best client. The next was HL. VHL because they bothered about the quality. I want a guy who thinks about quality. So if you get somebody like that, I'm the happiest. Then, as well as project leadership, consultancy and management. So this is something which all of you should inculcate, because you should be a leader. You should not be somebody who's also ran, I see, yesterday I've been talking to Mr. Sundarrao. I said, how come we don't know you? People like all of you have got so much background, we should all be thrown up. Should all be told to everybody. So this is one of the things that comes out of association, okay? Then, now recently I do a lot of peer review and technical audit. When we do peer review is when you find out all the loopholes. For example, I did a peer review for a promoter because the landowner was my client. And he had done 50 projects in 50 apartments in Bangalore. He was 51st. And when I went to design, the fellows had forgotten about seismic design. So when I asked his designer, what about seismic design? He says, where is seismic in Bangalore? People, then I said, wake up. Load up 50 projects and you are saying, where is seismic in Bangalore? This is sort of thing. So, peer review also has been a very important thing. Okay. Now we'll come to the real presentation, okay? So, anytime you have anything, you can just butt in, but I prefer that we do it in the end because of time factor. Otherwise, I'm a fellow who want it in between. So, what are we covering today? We are covering shell roof project. Now, why shell roof? So, I learned a lot of things in IISc doing that, and we had very good professors on the shell structures. And I said, why is it that's not coming in here? Then I found all of it coming in the US, but none of it is coming in Bangalore. So I said, I must put in shell roofs. So I'll show you, I put in shell roofs. Then large span, largely just roaded projects. Okay? Then as soon as you do a shell roof and things like that, and they see a PhD, then I think some of the people get some courage. This fellow can do large span, this fellow can do large roofing. So I got some of that. Tall buildings and tall projects. Very first project, apartment project, which came up in Bangalore, was done by me. It was in 1980. 75 passed out, 1980. The person came and he said, I want to put up a project. Then I have a big plot. Then you put multi-dwellings because I cannot break it into bits. I said, okay, we'll do that. Then I used tunnel form then itself, long before it came by L&T and all these people. Then, of course, I'm going to cover this all-house project in Almaty Dam. This is more for the people who are in the steel sector. You'll see what all we went through and how we achieved whatever we did. Also included in this presentation are the experiences in the various projects at micro level with respect to the genre and the organization which are circumvented in each of the above. So, India has got different personalities. There are some people who are very reserved and they don't open up. You have to break all that and make a team and take the best from each one and put it together like a collage. So this is what it was. Okay. So let's come to the first one. Our projects at a glance with anecdotes and nuances. Okay, multiple barrel cylindrical shell with feathered reviews. Two separate projects. Use of precast finical shells in large complex and not likely canonical shell. This is a sector on shells. Okay. Now, for those of you who may have read and you've forgotten or you may not remember, shells are curved members who are doubly curved or singly curved, generated by a generatrix or a directrix. So these are very capable statements. They are singly curved cylindrical shell or the doubly curved hyperbolic shell, which is generated with a hyperbola and a parabola. The secret to incorporation is to have straight line generators to simplify and economize construction. So what I did then, since I knew about shells, I said if you took straight line generators, the contractors would be very happy because the farm work is not so complicated. Things like that. I mean, this is what I'm talking about is 1975, 1980, when contractors were contractors. So, but I'm very happy to say that I had the best of them giving me the quality, getting to listen. Although they used nothing else they want to do. The first guy who came, I did a treatment plant in Kerala. And I told him, why do we do all this flat roofs? We'll do a shell roof for your treatment plant, for the filter shell, things like that. He said, what sir, what is shell roof? A leading contractor from Kerala. I said, see, there are roofs in. Sir, you draw it and show me the thing. I draw it and show. I said, sir, I can't do this. And I said, can we do a deal? He said, what? You bring the building up to the column. I will do the shell roof. On a no profit, no loss basis. I will do the whole thing. I will come there, sit if you want 1 month and do that. So we do that. I immediately said, very good sir, let me do it. FACT, Fertilizer and Chemical Travelco, they were the clients. Went there and told them, sir, you are going to be involved? Yes. Then you can do it, sir. Things like that. So that will happen. You can bridge that gap by this particular thing. So we got that. And then I learned a lot about feather edge beams. You know, these shell roofs have a lot of deep beams. You know, those are the costly ones. So I took I'll show you that. The curve, you know, the curve itself, I made that into a beam. So I will show you that. Okay. Okay. Now this is the water treatment I was talking about. This would have been a flat roof. This would have been a flat roof otherwise. So I told him, okay, you bring it up to the top and we'll do this. By the time the person came to building that, they become friendly with me and then asked me what is shell roof, how is the formwork done, how is the concreting done, is it more economical and all that. Then he said, sir, seeing me taking so much trouble, he said, sir, you don't need to take any trouble, sir. Just guide me, sir, how to do it. Tell me where formwork, what I can do. That's enough, sir. You don't take too much trouble. I will do it. I knew that would happen, but he's the right man to do it. I said, sure. And he achieved that. Okay? So now I come to the point where the innovation came. See, here is the innovation. This is a curve. Can you see it in the end? People can see it in the end? Yeah. Okay, this is one shell. These are all curved shells, you know. So this beam, all these beams, they would have been very deep, 4 feet deep, 5 feet deep, and all that. So what I did, I had studied this in shells. That you know, when the curve comes like that, this part can be the beam. So I put this particular feather edge beam, cylindrical shell for water treatment plant with feather edge beam. Very first project of career, wanted to break old flat roofs with filter hall, convinced contractor of economy and construction, made a deal to do it myself. Homework was easy in Kerala, and in Kerala wood is it's in their blood. They know what to do with wood. So I told them that homework can be made in wood and easily. So then he agreed for that. Most people agreed. Absolutely winner, especially world's first feather edge roof. Then I was told this, all in theory in the books, has not been done anywhere in the world. But there's a theory, somebody has done research that it can be feather edge. So I said, maybe then I told my professor who taught me shells. So him, I had to tell him. So then, is it that I'm the first person to do it, or we are the first person? He said, I think so. So that's why it came to maybe the boldest venture at nascent stage of career, immediately after PhD. So you see, the thing is the boldness. So I am telling you all this is many people who are working on different projects. That boldness you must have. It's not that you bluff people, but you have the boldness. Go to libraries, study all that, then be ready for whatever it is, and improve efficiency from 50% to maybe 75%. Then you take up all this. Otherwise, you will not be able to do this. That was the first shell and it was in 1988, 38 or something.
It is the confidence level you have.
Yeah. Not only confidence, it's all teamwork. See, you know better what form work, I know better about design, he knows better about architect, something like that. All of us put together, what he doesn't know, I try to make up. What you don't know, I try to make up. Don't say I did it, we did it. It's sort of situation. Now, this is avoidable bad experience. Okay, when I did the project, I had a lot of bad experiences. I just go through that for the benefit of all of you. See, the found site group not bothered or reading the important aspects in construction given in drawings, such as centering schedule, concreting schedule, and decentering schedule, which would have been calamitous. See, when I issued centering schedule, then I gave concreting schedule. In the days I was really efficient. I would say that's why I said we are 35%. I gave all of that in drawings. And the people in the site, they said, is this all required? What is this? What is this concreting schedule? What do you put concrete? Just pour from bottom and you put to the top. I said, my God, you are at a different level. You better follow this. You have to be strict. You can't be lenient. You say, do chata hai, do whatever. You have to be strict. No, you better follow this. Or I'm leaving this site and going. You got to be that way. And I told him, if you pour from bottom, the bottom portion will thicken up. The concrete will flow down. You have to pour it in concreting schedule. What is decentering schedule? Even a flat roof, you must know how to decenter. You can't just decenter from anywhere to anywhere. The shell is both like that. He says, sir, I asked a person in Calcutta whom I know who did shell roofs, and he said, you don't bother about all this. Just remove centering, everything will be all right. I said, did you ask what is the parameter of that shell? What is the parameter of this shell? And then decide on that. And if you are not assembly engineer. And he says, okay, sir, I'll do whatever you say. Then the client was listening and he said, you better do what all you say. I've taken so much pains to give the centering schedule, concreting schedule and all that. And everyone wants to throw it out and just do whatever is doing at home. This bank. The owner supplying, okay, this is another thing. Many of our failures are also due to the owners. And, don't mind it, all of you, because even the owners, they interfere and they come and say this or that. They had some steel left in some other project. They said, why should we buy new? We supply that one. I said, if it is okay, if it passes the test. Then that chief manager is saying, it is our steel. I said, whether your steel or my steel or his steel. Steel is steel, that has to be tested. Then he said, will you come and see it? I went and saw there, in Canada, it corrodes. The atmosphere is bad. So 8 mm has become 6 mm. And the ribs are gone. Then I told him, sir, this will be treated like a 6 mm. This will not be 8 mm. Why, sir? Sir, you are a civil engineer, come and see. See this. Then he turned and said, sir, you are the boss. You decide what. So if I had not had the guts to tell a chief engineer like that, then where would I be? So, and then owner supplying, and form work persons, then they had bamboos as form scaffolding, And what do they do for connecting each other? The double staging and things like that. They are putting nails. They are putting nails for junctions. This is a point contact. Nail is a point contact going through a bamboo. You said your grandfather was a former contractor, father was a former contractor, and you are a former contractor. Is this what you do? Then what can I do, sir? This is the contractor, what is happening? Then I tell also, take wire ropes which are lying, coil ropes, which are lying all over here. It's very famous there. Tie them up. What do you put the rod? I will do that. No, why is it we are like this? We should be, we should be up to it, So this is what I saw in this. That is an avoidable experience, but this was when I started, but I was bored because of a lot of factors, because I was a debater and sportsman and things like that. I could tell people how I didn't care what happened. Okay. This is the second one. I did the same multiple valve cylindrical shell for BHL. Now I was confronted by seniors, directors of technical director of BHL, from the Infobee people to make presentations with them. So when I did that, it was an experience which was facing, shall we say, or all the senior people or clever people. They are not going to listen to anything that you say. They'll grill you. So I went through that. Then we did a canteen project, which was 6 meter by 6 meter column grill. It was a flat roof. Then on top of it, there was supposed to be executive dining. So they wanted the 6 meter columns to go up and flat roof on top. Actually, you are calling it executive dining, and you are putting 6 meter in grade. Why don't we remove all that and put a shell? He said, is it possible? I said, what is not possible? Anything is possible. Then he said, shell? Sir, who's there to do the shell? Why, I can give you something. Can you give 3 people who can do the shell? I'll give you 4 if you want. He said, if you give me 3, I'm good. I said, I'll give you 3, sir. You can check them out. And then I said, if you don't have column in the middle, 18 meters span, if you don't have 2 columns, it's a hall. So you can do whatever you want, interior, you can partition. And he said, so he spoke to the other fellow. He said, when foreigners come, we want separate dining in the executive. So our executives can eat in one portion, in 1/3 we can put for foreigners. I said, there you go. This is what you can do. Sir, you're on. Your cell is on. So this is what happened. So what I did was, I suggested a shell roof instead of spanning 18 meter column, resulting in a column 3. Suggestion accepted, but on condition of supplying 3 different builders. Challenge accepted, taken forward and executed, especially the incorporation once again of featherage beam was designed. Now the technical director had to be convinced about featherage beam. Then he turned around and said, what is featherage beam? I said, sir, will it be strong? He said, so come to Alvai, Kerala. We'll go and visit and come. I've done it. Just because I've done the first one, I got the courage to tell him, come, let's go and see. Sir, if you have done it, then you are on. So that featherage beam came again. Especially the incorporation. Project successfully executed. Later got reports that management got a column-free congregation hall for various use, including, I think even the fellows over there, the fellows were union fellows, wanted to have meeting. So there is no hall anywhere. They were given this hall for the union meeting. Contractor that delivered wonderful quality from beginning to end, even requesting high involvement from me all the way. Then I gave 3 contractors, they tendered and all, and we gave it to one of the contractors, but all 3 were damn good in quality and things like that. So the contractor said, sir, your involvement, I'll be pestering you off, and I said, do it in the middle of night also, no problem. So like that. So we got that. Then we got tremendous respect from the BHL union manager. The technical director went and told everybody in BHL all over the place that in Bangalore they're doing something very innovative, go and see. So we got very good deal from all this. So, but for all that, I had to create something new, no? It's not for anything if I had done whatever everybody does, maybe I wouldn't have been able to do anything. That was the second shell roof, and there you are. See, this is the ground floor dining, and this is the first floor, which is column 3 and things like that. Next, please. Yeah, and there is that, again, featherage beam, and we have done it, things like that. So, okay. Now comes, after this, don't get bored of shells because they told me one part should be on shell particularly. So I put everything on shells in one part. You'll get other interesting things after. This is not interesting to you. But remember that there is something called funicular shell. Okay? I don't know how many of you know this. So when I went to SCRC in Chennai for a seminar, I heard what research they're doing. They have contemporary trends. No? They told me that they're doing a funicular shell. They're doing some research on funicular shell. I said, Professor G.S. Ramaswamy, he was the man who initiated this thing, funicular shell. Because funicular shell is the reverse of a catenary. If all of you know what's a catenary, catenary is the rope, the shape of a rope. If you let it hang, it will be totally in tension. If you invert it, it will be totally compression. So they devised this funicular shell to be totally in compression. So So they said, and it can be done and all. Because human thing is an Indian, what shall we say, patent. Okay? So then I proposed this, it was proposed to construct a large multi-storage stores complex in BHL. They wanted a large multi-storage stores complex, central stores complex. At the concept day, we discussed what could be done differently. I said it's a large area, flat roof, on 6 meter, 7.5 meter by 7.5 meter grid or something. What are we doing? Simply pouring concrete left, right, center and using a lot of steel? Why not we do something different? I said, what can be done? They said, each bay you can take a funicular shell. So we did that. Proposed 1.2 meter by 1.2 precast funicular shell to be used as there were typical grids of column, 7.5 or 7.5, with high bay having 8 meter height. There was a high bay. So if you asked somebody with 8 meter high bay, the centering cost would be equal to the cost of the flat roof. People charge you for the height. So this is what was avoided. Funicular shell is an inverted catenary, I told you. For economy, masonry molds are used. And funicular shells could be used, could be done even with hessian cloth. You can just hang a hessian cloth and then pour concrete. You will get a catenary. You will get a funicular shell if you invert it. So, but you can also do in masonry molds. That's the economical way. So we tried out the masonry mold. With these, the formwork requirement of the roof would be only one strip centering below the grid beams only. You'll see in the photograph afterwards. BHL technical director was aware of this shell, and he had heard of this in the SCRC. Luckily for me, I had gone for a conference somewhere, and somebody had said something, DS Ramaswamy group had said something about funicular shell. So the technical director said, somebody had told me about funicular shell in the conference. So, at least two who, Also, here also I said, who will do the job? Give us 2 contractors or 3 contractors who can do this job. Then only it's all. I said, I'll give you 3 contractors. The background is, all of you who are contractors here also, you should join up with people if you are really doing quality job. If you are a quality person, you go to a quality designer. Then you can do something innovative. Otherwise, you'll be doing the same old thing and going home. And at the end of the career, you wouldn't have anything to show. Okay, so I gave them 3, and we did. And one of the interesting thing in that tender was, I had quoted that each shell would cost 125 rupees in those days, from 1978. But the tenderers, one of the senior tenderers, I think Dina Engineering or something from Bangalore, he had quoted 100 rupees, whereas I had estimated 125. Other fellows had seen my estimate or God knows what. Other 2 people quoted 150 and 175 per shell. Then I called the person who said 100 rupees. I said, do you know what this is? He says, my friend is vice, what's that? In SCRC, in some position. He is not vice president, some senior scientist or whatever. Parmeshwar, Dr. Parmeshwar. You must be knowing Parmeshwar. He is there. So I have seen funicular shell there. I know what it is. I know what masonry is. I said, you're the man to do this job. Quality contractors are the backbone to all consultants. If you give me quality, I can give you economy. If you don't give me quality, forget it. Okay? We have saved in so many projects where we have done. In the beginning, when I started practice, 90% of the project I used to knock off. Because I used to have the contractor along with me to give me quality, and I would do the different design and convince all the people, including Jalmanja, HAL. So, they would all say, okay, this is the way to go. Okay. Then, also we were asked to test the shell and then only use it. Then they said, you are doing something called masonry mold. You are saying it's only 25 mm thick shell. How is it going to stand? With other people, other than the technical director, they are standing up and saying, is it strong? Will the roof fall and this and that? I said, we'll test it. At site we'll test it. So we tested it. There were having crane movement also where we suggested additional care. Then there was a crane bay. So they said shells will vibrate, roof will vibrate. I said, why? We'll take care of that. Then instead of having a single layer for temperature reinforcement, I'll put a multi-layer temperature reinforcement and put a little more reinforcement in the beams or whatever, shell will be the same, it will not vibrate. So it happened that we also took care of that. We succeeded in satisfying all of the above. We completed the project systematically. So you know along the way what is the journey, what you go through, what the different type of people that come here in the hall. We have different types of people, each having some thoughts. So it is, we should integrate with each other and see in each other what is the good of each person, not see the bad of the other person. So if somebody comes along and says, I can do in steel, we're just talking about steel, when I did in steel, if you can give me good quality steel construction, I'll do in steel. So first you have to check that out, otherwise don't enter. So it was finally worked out by the public sector auditors that this innovation resulted in huge total project saving of 11% in total cost of the building. I didn't know this. They've got a public sector publication. There they have mentioned BHL has done something new and things like that. So economy also comes. Now what is this? What is this funicular shell? Okay, here you are. This is a unit, one single unit. They're all assembled together like that. And then after that, here also shells come, and this will be the beam. Note the shells easily transmitted on wheelbarrows to position, and it is so light because this is only 25 mm thick on top. The shell, it can be shifted in a wheelbarrow. Also, minimum side forms to beams resulted. See, side forms here for the beam, the shell itself forming part of it, things like that. So the contractor, I'll tell you about it later. Yeah, contractor found reduction in formwork resulted in 50% saving in formwork. So double stage formwork, 50%, that because you have to put only strip foundations. Okay, this is the plan to tell you what is. These are all individual funicular shells, and that's the beam grid. And the beam is also whatever. You will see it later, I think. Okay, there you see the beam. Sorry. There you see the beam. You see the beam, lateral beam will think like that. These are the columns 7.5 meter. And you see the amount of concrete that you have to pour. This is only 25 mm thick on top. This is the skin reinforcement, and wherever there were cranes, I put double layer and things like that. And this is the way it was. I'm just showing it so that you will understand how easy it was or how difficult it was. Yeah. Okay. Now come to the test part. So they wanted test, and they said you should be here whole day during the test and all. The conditions they put. Me whole day away. We give to a testing apparatus. No, we want you to be testing. I said, okay, all this comes about. So in India. So we put this, and then when we put this, we put masonry all around, put the shell there, and put sandbags on top. All the officers and all the staff of BHL, they would not come below this. They're all standing 50 feet away. It's going to collapse on their head and things like that. And me and my assistant were going below this and trying to see what is the cracking load. Then the shell would crack. So those fellows said, you fellows have got guts. Your heart is very strong. You won't come in the bottom. Then 100. We were supposed to test as per IS 25% more. Then 125% is what it's supposed to take. I said, don't stop, I want failure. So we went on and on and on and went. So you see what happened. Many qualified and mostly afraid to come below the shell where first crack load was to be recorded. If any, shells didn't fail even at 400% loading, and the test was stopped. So see the confidence that they get, that this news travels all over India. So all the BHL units, it took 400, this photo was put, and they were all told it took 400%. They said, who thought of this thing like, So it came back to me. Then I said, not me, yes, I'm sorry. But we transported it on the side. Okay? And that's a beautiful thing that you get at the bottom, at the end of it. Nation saving resulted, and also many professional companies came to us, design a building with nuclear shells if feasible. Next thing is people come to you and say, earlier you have done field classes, why don't you come to our project and do something, things like that. So be ready for all of that and take it up. And that's the way it is, but be careful who do it. Quality was very good in BHU. Pellicular shells are extensively used now in roofs of ground level reservoirs in spans of 8 meter by 8 meter column width. I don't know whether people notice who do underground tanks and things like that. When it comes to the roof, we all do pellicular shells. 8 meter by 8 meter span, not 1.2 meter, 8 meter. So that's the way it was. Okay, those are the two shells on the paper. The last one, the shell is the conite shell which I presented. I don't know how I'm doing my time. So let's give you a little warning. After I think two panels, I will stop. I will give the presentation. Continually. Shells are finishing up. This is a conite shell. So then we got a sports module, stores module in Variant Axle plant, now called Railway plant in Bangalore. So then they said, what can you do? I said, we can put a Northlite conite shell. Then the people who were there, who was general manager, were actually from IS. So he turned over and said, this guy knows what he's talking about. So that was a bonus for me. So then I said, then he said, is it suitable? I said, yeah, why not? So it was proposed by Variant Axle plant to have a 5-module stored facility with reinforced concrete roofs, all flat. And then they had 5-meter cantilevers, or as I said, canopies, combined with it. Only shell roof specialists were invited, and a Northlite conidal shell was asked for on a turnkey basis. Because I had shown them this Northlite conidal shell photograph, they said, told other people, consultants, we want Northlite conidal shell. So another fellow took boldness and quoted for that, and because I got the job. Design was to be peer reviewed by a reputed institute, and here comes the thing. So they say it has to be peer reviewed by ASC or IIT and all that. I said, I have no problem. We'll do it at IIT. And whom do I go to? The professor who taught me shells. He is going to approve my shell roof, So, he turned around and said, oh, you are bold chap. You 5-meter cantilever, canopy, coupled to the sting, edge. How is it possible? Sir, I have done finite element analysis of the whole thing. I have not done, but I have done 3D. Sir, 5 meter was also included in all the analysis. The edge beams have all been tested for that. Told in Kannada. Convince about it. I don't know whether you know Kannada. You say something and convince everybody. My own professor told me, I said, sir, you taught me shell. But I am telling you that I have done it. If anything is wrong, you tell me. He referred to finite element group. And they said, this is fine. There's no problem. Then he said, the shell will, the edge beam of the shell will have some effect in the shell. What have you done for that? Sir, even beyond finite element, what you want? I've done finite element with the shell and with the edge beam and with the canopy. Then I was just thinking, I said, if you want, I'll thicken the shell at the bottom, such that the edge disturbance won't be there. Oh, what convince about it. He said again, convince them first. So, but, the people who taught me, I should pay respect to them. Because after all, they are the people who laid the foundation for all our thinking. So it was. Design must be peer reviewed. We succeeded getting the assignment in stiff competition. I tell you after that what happened. The other group was somebody from Bombay, big consultants, they put it. And they tried all their might to get the job. And I didn't go anywhere. We were L1 and we had to be entertained. So I went through the bill. They fried us. Those people are giving them idea how to throw these fellows off. The marketing guys are very good in telling you how to throw anybody out who's L2 or L3 or something. We never relented. So we succeeded in getting it. Design was directed by IIT Bangalore instantly by a professor who taught me shells. That's the beauty of it. I would say then he's done a very good job in teaching me shells. So that's all I can say. But he is the one who initiated my thinking into shells. The thing is, they motivate you. Your teacher, motivate you into thinking something different, something bold. That's what he did. consoles were the 5-minute canopy attached to HB. 3D FMRS had been done by us. Our design was finished with 52 tons of steel. The city of design. Then they told how much steel. Somebody told this fellow is very economical, I think, with packet element and all. How much steel is he using? They asked me how much steel are you using. They said, you're not given the job to us. You're asking how much steel you're using. You mean preliminary what you have done. I said, I will tell you. What we do in our office is when we get an opportunity like this, for 15 days we sit on the project and put all the brains there and the preliminary design is made like a final design. So we had made and we put out that we are going to use 52 tons of steel. And then we found that that the competitors had quoted with 85 tons of steel for the same module. They had very reputed company they quoted. Then people said, these people, audit will be there. Then they will ask how you gave to these people for 52 and these people are saying 85. They didn't ask them before, they asked me after asking me. Then they put in a condition in the code, work award. They said 52 tons of steel must be used. If anything more is to be used, you have to put from your pocket. Anything less to be used, you have to give it to Wheel and Axle. I said, what sort of contract is this? And they said, sir, our auditors are insisting because they are told somebody is telling it needs 85 tons steel. I was shocked to see somebody designing with 85 tons of steel. In fact, if I had not got 52, I had got 49. I had made it 52. I said, okay, 15%, 10%, 5% more. So why should we give back steel to those people? And we got the job. National saving result. Now, what's the net result of this? It's from 85 tons, the job was finished in 52 tons. And things like that. So, that was the north shell. Okay. This is the connect shell roof with the north lighting. Yeah, there you go. That's a beautiful module that we did. And you can see the 5-meter canopies, on both sides. Because this is stores and for that. Now for the people who want to work on shells, you may say Ram Prakash said the shells can be done and don't start getting into shells immediately. That's something you should keep in mind and be back up. I'll just put it such that it will be useful for you. Definition of shell, sorry. Okay, what's the definition of shell? Third for directly I told you, W of singly, thick shell or thin shell. If you make the shell too thick, then it's likely to fail. You have to take the thick shell theory, but the thin shell will not do. And example of singly curved shell is cylindrical shell. Doubly curved is hyperbolic paraboloid. Simpler forms are made using straight line generator. Ease and saving of formwork is the key. The major thing is the formwork. Analysis varies with use of membrane theory as well as bending theories. An efficient structural form due to its geometry. So these three which I have already presented here. Okay, now what are the notable shells you have to note? If you have not noted already as a civil engineer, the first one is the Baha'i temple in Delhi. I don't know how many of you have been there. If you have not been there, please go there. You are not a civil engineer if you have not been there. The guys have done a fabulous job. You must just salute the guys. Especially the formwork and the way they put the formwork. It's a double formwork on the curves and they removed the outer ones, went on concreting according to that. It's a lesson for everybody on how to do a shell and things like that. And unfortunately, nobody has given them the award like what they should. Maharashtra, they got some award. They will give you a book which you can buy when you go to that Baha'i temple thing. It's worth buying that book which will tell you the full history of how it was done and things like that. And there I saw Maharashtra chapter American Concrete Institute gives second place award. You should get the first place award in the best, like a Nobel Prize it should get. And Indians have constructed. So all of us Indians should stand 2 inches taller. It's done by Indians. But designed is everything from London. But done by Indians. All of us should be proud. The guy did it. The L&T guys are the fellow who did it. With double formwork and things like that. traveling forward, along the to get the leaf. Idiki Arch Dam, all of you must be doing about Idiki Arch Dam, because we had a professor in IIC who designed the Idiki Arch Dam. Then Matru Mandir in Auroville, that's also a shell roof. Hyper shell at Infosys Bangalore. If you have not seen the shell in Infosys Bangalore, please visit that. It's done wonderfully and it's travelled all over the world that these people have done this shell. As thick as 5 inches, all the shells. Think of that, hyperbolic paraboloid for us. Canteen complex, huge work. When I saw that, I went and gave a salute to the contractor who did it first. Then I went to the consultant and gave a salute to him. I said, guys, you have done it. So that is what you should see. This is what I have done so far on shells. Okay, what are the recent developments in shell roof constructions and the note on cautions? Inflatable forms have come. The form you can inflate now. You cut it to the shape and this and that, inflate it and pour the concrete. So inflatable forms, monolithic dome institute. This is something which has come up. They've been in Europe. They've built buildings, houses with a monolithic dome. There is a monolithic dome institute itself. Curvilinear houses. The professor in Europe has made, that was not in 3D, which is there now, 3D building, but this is before. He has made his whole house into a curvilinear in plan as well as in elevation. Now the caution for people who want to run into shell, rigorous study of the parameters and the analysis required. See, I did the FEA analysis, otherwise I wouldn't have been able to get whatever I wanted. Integrated substructure and shell structure analysis, likable. This is done in that canteen. Non-linear analysis tools help. Buckling aspects are very important. The local buckling problems will come. Then I have a famous statement of my own. After 5 years of practice, Professor K.T.S. Saiga from Indian Institute of Science, I met him in an international conference. He said, he was my professor, guide. So he asked me, what have you seen in practice? I told him that there are 2 types of engineers I have come across. He said, what are they? I said, one type of civil engineer is, he will go to the level of the problem. Yeah. He said, who's the other one? He said, the second one is who brings the problem down to his level. One takes it to the level of the problem. The second one who brings it down to his level. If you look at a flat roof and you say, a shell is also a flat roof. One fellow did it in my own project in Mysore. I was doing Ganapati Sachidanand Ashram big hall. Entrance canopy, they wanted to do shell because I had done, I think, that fellow from Bangalore is very famous consultant, famous consultant actually. So that project manager of my project said, sir, we are doing a shell here. Why don't you see what we are doing in the I went and saw there, that fellow has put just like flat roof, he'll put rod and crank rod and things like that and wanting to cast it. Luckily he had not cast it. Then I said, who has done this? Sir, he is teaching in the college. He's a professor, he's doing a lot of work. I said, if he doesn't know about shells, he better not enter that. So he, instead of going to the level of problem, he brought the problem down to his level. And it should be gravity if he does. So that is my own concoction to my professor. And he said, very well put. Give me credit for that. Consult senior peers. If you can't, you don't need to feel, what shall we say, despotic so that you're not able to do shells. No. Go to somebody and take peer review, take senior shells. Tolerance is important. Then tolerance, in Anna University itself, one shell failed. I don't know whether you people know about it. It fell when they did for this thing, representative they did. It fell down. Then a big inquiry about why it fell down. You know why it fell down? Because his concreting schedule, decentering schedule, I was not bothered about it. Just give it to some fellow. Build it, I said. This is the way it should be built. That fellow put concrete and then it bulged. Some portions were more than, it was 5 inches thick or something. Some portions were more than 7 inches, 8 inches in some places. And some portions it was 5 inches. And concreting was not done methodically. The whole thing failed. So tolerance is also very important. Okay. this is the end on shells. So I think we'll just take a break and we'll go to the other parts. I don't think they'll be so rigorous as this one. So we'll stop for some time. Okay?
We have a sponsor presentation.
Yeah, sure. Please go ahead.
Thank you, sir. Now I request Sri Ram Murthy K and Arif Pramod from Kakinada Industries Private Limited to present their product.
Accei Kakinada is a pioneering engineering organization which was established in 2008 with the vision of creating a versatile engineering background. So our production facility is built on 15 acres of land at Mobilpet, Sadashipet, and is equipped with state-of-the-art infrastructure. While setting new benchmarks for the operational efficiencies, the plant is also amply equipped with advanced machinery such as laser cutting machine, laser welding machines, CNC plasma profile cutting machines, CNC spot welding machines, beamline star welding machines, CN jet purlins and wet machinery, decking and roof sheeting, roll forming machinery, among others. So we have capacity of around 50,000 metric ton per annum. Is Mr. C.H. Anand Reddy is our chairman and managing director. So Mr. Reddy obtained his degree in metallurgical engineering from RIC Warangal and is the recipient of gold medal. And he also holds a postgraduate diploma in materials management from the Indian Institute of Materials Management. Mr. Reddy had a great stint at Hindustan Aeronautical Limited and Nagarjuna Steel Limited. So he joined Pennar Industries in 1986 and worked in various departments and was appointed as executive director in October 2000. And he retired as a vice chairman in the year 2012. Mr. Reddy was instrumental in turning around Pennar Industries from a loss-making entity to a profit-making company. And under his stewardship, the company turned from a turnover of 76 crores to 1,200 crores by 2012. He has been awarded as Manager of the Year by Hyderabad Manager Association in the year 2010 for his outstanding services as Managing Director of Pennar Industries. So now our group turnover is more than 250 crores under his stewardship. We have our own design and detailing team, in-house team, and we have more than 25 members in design and detailing team. So we are using latest softwares like StatPro for designing the projects and AutoCAD and Tekla model for detailing. Yeah, you can find here some of the products we have. So you can see pre-engineered buildings and railway equipments also we fabricate and we supply to ICF, MCF, OSCF. And we do road safety crash barriers, and we supply building components like purlins, skirts, and roof sheets, and all roof sheets also we supply. Deck sheet also we supply based on the requirement. Yeah. Now major projects will be taken care by our colleague Mr. Yeah.
Good afternoon, one and all, and thank you very much for giving this opportunity. Like some of our major projects are like MS prevented renewables. Like this is for solar panel glass manufacturing, and it is at Rajahmundry, which is in the stage of completion, almost the completion stage. And It is of across 2000 ton project, and this we are going to complete within 8 months of time. And our major scope is design, manufacturing, supply, and installation. Then this entire building is design was done by us. And here the major critical part is this furnace area, which is of 24-meter height. And this is one of the landmark project for our company. It is a waste to energy plant. Through Ramki infrastructure, we have done this project in Hyderabad. It is of approximately 2,500 tons. And this one we have done during COVID first wave. And we have completed this project in 10 months time. And this is one of the project, it is a nearly height of 57-meter height, one of the project actually we have done this. And this is for Amazon data center, through Tata Projects Limited we have done this. And nearly it is a 1,600 metric ton.
Go back. Yeah, actually this project we have done during second wave of COVID, and we have done it in within 10 months period. So it is one of the milestone projects for us.
This is for Aparna Infra Housing Limited, and we have done this at Trian roof, which is of approximately 800 tons. This is for rain carbon in Vizag. It is of 400 tons building, and we completed within 4 months. And this is for Eastern Film Tech. What they do polyfilms actually. And this is of 2,100 tons, and we have done this project in 11 months of time, even including the second wave of COVID. And this is for 350 tons. This one we have completed in 4 months. And this is for Procter and Gamble. This is approximately 150 tons, and we have done this project in 4 months. And this is for Chirpal Polyfilms Limited, which is of 250 tons. We have done this in Hyderabad in the record period of 5 months. This is for Vijay Polyplast, 380 tons, and we completed this in 4 months of time. This is for the NCC Crowns, 350 tons. This is a library building actually we have done for in Jamshedpur for Manipal Tata Medical College through Tata Steel. This is one modern rice mill, which is of 100 tons. We have completed this in 2 to 3 months time. This is for Raitu Velika for Government of Telangana. Here we have done 252 buildings of each 10 metric ton, were erected across the state of Telangana in the span of 3 months. And this is for Vedaganga Seeds, it's a 100 ton project. This is for Tata Advanced Systems Limited in Hyderabad, which is of 200 tons. This is for Ahmedabad to Mumbai L&T Metro, L&T Bullet Train, L&T Bullet Train. Please continue.
We got 6 depots from L&T, and we have already completed all the depot buildings. After that, we got 2 more buildings for station buildings. Those are around 2,200 tons. So now it's at advanced stage, the buildings.
This is for Fab Industries. It's a warehouse project in Nashik, Maharashtra, which is of 750 tons. And this is Tata Steel ITA workshops for Government of Karnataka, Karnataka state. Actually, these are nearly 100 buildings of each 20 tons. We have erected these all buildings in the span of 3 months in the entire state of Karnataka. This is for KBK Chem. It's a raw sugar warehouse for Renuka Sugars in Haldia, West Bengal. Actually, the critical part is here is I say slope is different. It's not as a normal slope like 1:10 or 1:20. It is nearly 1:5, 1:4. 45 days. This is for TCL TV manufacturing in Tirupati. We have done this for CCTV India Private Limited around 2000 tons, and we have erected this project in 6 months of time. This is for Coca-Cola, Hindustan Coca-Cola. Through Ratna Constructions, we have done this. Nearly 850 tons in Odisha. And this is for Varsha Food Park, Sri Varsha Foods in Tirupati. This is for TCL TV. This is the first unit we have done for TCL TV manufacturing. This is for 3F Industries in Krishnapatnam Port. Likewise, CPF India Limited, like it's in Erravaram, it is of 550 tons. And this is for Ilios Breweries. This is one of the landmark projects for us in Vizag. Through Ratna Infrastructure, we have done this for Refra Technique. It's a German company. Like the project is 1100 tons. And we have completed this, it's almost nearing the completion, and we are about to complete this within 9 to 10 months. This is for Chiraharit Private Limited. It's a warehouse of 1 lakh SFP. It's in Vijayawada and it's already completed, which is of around 400 tons. And we have completed this in a span of 7 to 8 months. And these are the few new projects awarded to us recently. Like one is from JK Paper, which is of 350 tons in Telangana. One is for Century Panels in Kadapa for 350 tons. One is JSW, Cold Shed and Warehouse in Bangladesh, 330 tons, and Amar Raja 1000 tons in Hyderabad. It's a warehouse project. And this Navi Mumbai International Airport, recently we got one building in Terminal 1 Airport Terminal, which is of 2200 tons. And one for PNG in Delhi is around 300 tons. And one is of Microsoft India. This is the large project we received recently, 400 tons, 4000 tons. Sorry. And this is for Mumbai Speed Rail, bullet train. We received station buildings. These are the on-hand projects recently. And this is the sample 3D model of the Microsoft India project, which we have developed in Tekla. From next, my colleague Yama will continue.
Yeah, you can see our plant location. So already I introduced these points.
Do you have an expansion joint for that?
Pardon me?
Do you have an expansion joint for that?
Already
We are expanding almost 2 more warehouses next to this.
Yeah, sir. Whenever it is more than 120 meters special as per design, what people consider as that they will restrict. So we will take care of all the design points as it is in CCP on wind speed, all the things we will take care of. This is a plant and machinery we have. You can see the wave line. This is our beam. This is our beam line. This is a steering machine. And this is drilling machine. All machines we have latest version. This is the process while fabricating the steel. You can see the box column. Already Mr. Aditya told 57-meter height building, which is one of the tallest buildings in India. So we have one for Ramki Grove, which is a waste to energy power plant. So there we fabricated all box columns. Go back. So you can see the all box column. So the size of the box columns are 1.2 meter by 1.8 meter, and each column of 12 meter is 18 tons weight. And you can see the slot, the gap. You can say people used to enter into that, and they used to weld some stiffener plates inside the column. So it was a very tough job for us. And we have done this project during the first wave of COVID. this is our short blasting and paint booth. We have our own standing machine, SSR machine, and this is the project East Polytechnic we already explained, where we did this we rolled it at a site and we erected the SSR roof. So these are the certifications we have. So ISO 9001 2015, we have IRIS certificate where we can supply our railway components across the globe, and we are Innotech ISO 3834 and 2005 certificate we have. So we have we are already certified as WPO certification, where we can do PVs in railways, and that is RTSO. We are also RTSO approved, where we can do that ROB projects across India. So these are some more certifications we have. You can see our clientele. We have done projects with all like BHL, Tata Steel, Ramkey, AP Genco, BGR Energy, Greenco. These are all clientele. So some more clientele. Just Ramesh.
Let us have our corporate video.
Just for 7 minutes, please bear with us.
The sweeping changes happening in the global economy have given rise to an immense demand for coal-formed products in India, the basis for an array of coal-forming enterprises. Leading the way among them is Kakinada Industries Private Limited, a reliable name in economical building solutions across southern and western India. Kakinada Industries was envisioned by first-generation entrepreneurs with hands-on experience of over 25 years in the realms of coal forming, light and heavy engineering fabrication, including railway coaches fabrication and pre-engineered buildings, among others. With factory anchored in a sprawling space of 50 acres at Bomenpet, near Sadashivpet, Hyderabad, in India's youngest state, Telangana. We could make this place a vibrant place. A lot of activity here. Now we are spread over 15 acres of land. We employ more than 6 to 700 people on average every day. While setting new benchmarks for operational efficiencies, the plant is also amply equipped with state-of-the-art machinery, which includes laser cutting and laser welding machines, robotic spot welding machines, CNC plasma cutting machines, CNC press brakes, roll forming machines for various cold form profiles, roofing profile machine, deck profile machine, and saw welding machines. Backed by in-house capacity to deliver 30,000 MT per annum of cold forming sections up to 10 mm and light engineering fabricated structures. A journey of pioneering innovation and engineering excellence. Kakinada has design capabilities and modern resources to scale new frontiers of technical excellence, coupled with committed high degree of service and quality. Kakinada is the immaculate manner
in which its consultants analyze all kinds of PEB structures, ranging from low to high complexities. The core team has expertise in innovating customized economical designs and uses specialized software packages and cutting-edge computer hardware. Kartikeya's purlins too have gained wider acceptability in a myriad of construction activities, such as construction of steel buildings, industrial warehouse, a PEB, or even a complex turbo generator building in a power plant. Trust Kartikeya for a wide range of sections such as Z purlins, C channels, lip channels, multi-beams, angles, and many more profiles that are available in a range of 0.9 mm to 8 mm. Kartikeya offers best roof sheeting solutions in this part of the world with long-lasting materials and immaculate quality. Made from high-quality materials and available in bare galvalume, color-coated galvalume, color-coated galvanized steel with thickness ranging from 0.47 mm to 0.6 mm. They are designed to render an aesthetically attractive disposition. An impressive range of roofing accessories complement the roofing sheets. A quality composite deck sheet. Top deck is a steel profile with ribs, embossments, which helps in binding with concrete slab and together forms a part of the floor structure.
Matter of great satisfaction that in short span we got recognition from the Indian Railways for manufacture of stainless steel coaches. It is to be noted that the Indian Railways are modernizing the railway tracking, railway full coach system, bogie system for higher safety, for higher comfort of the passengers. In that direction, we have put up a facility, modern facility for manufacture of railway coaches, including the underframe parts, and we have been top 10 people for manufacture of the railway coaches.
From manufacturing parts of railway wagons to developing unique requirements for rail coaches. The railway solutions are delivered under the watchful eyes of Kartikeya's visionary leadership. Kartikeya manufactures and supplies a wide range of guardrails and metal crash barriers. Aimed at offering a safer operating environment for all road users, the end-to-end solutions embrace manufacturing as well as installation. The competent team at Kartikeya specializes in solar module mounting structures and can provide a range of solar segments such as ground-mounted solar projects and rooftop solar projects at short mounting times. Meeting the versatile needs of his clientele that represents all segments of the economy. Kartikeya Industries is all set to emerge as a leading name.
So it's all about Kartikeya Industries Private Limited. Thank you all. Thanks for giving us this opportunity to present you. Thank you. Thank you all.
Thank you, sir. I request Ram Prakash sir to continue the session.
I hope you're not getting bored. You can stop me anytime and I'll be any questions, so we can break the monotony. Thing is, it's valuable to pass on some things and also learn from you some of the things. And this presentation which I saw the sponsors, I think is good. The quality of the thing is also very good. Yeah. Point to this. Okay, next we'll be talking about the large span and largely loaded structure projects. Some of them are really large, like the space structure was 300 feet diameter. We'll come to that. Okay, I talked at the beginning about one of the roofs which are all in pre-stressed concrete, about 85 feet span, 75 feet span and all that for a basement, double basement. There were 6 tennis courts on top. The basement was below that. This is for this Accei Academy of Excellence International School in Bangalore. The deck was of pre-stressed concrete, PT slab, top exposed to sky, subjected to weathering and temperature variations for 6 tennis courts of double basement. See, the important aspect for people who want to get into the designs of this is this weathering thing. The tennis courts are all exposed. It is not a covered tennis court, so a lot of weathering there. So temperature variations and things like that. Whenever something comes to you as a project, you've got to put it in its perspective. If I had said that it's just a roof and just cast it and all that, but it is going to be used as a tennis court. So a lot of things are involved with that. I put in GI fiber reinforcement to the exposed pre-stressed concrete roof slab, so that you don't have the effects localized of the temperature. Then having spans of 75, told you this. Expansion joint provided. Then expansion joint has to be provided between the tennis courts. So a lot of things involved with those particular things, all taken care of. Take pre-stressed PT slab, subject to weathering, added fiber, next one. Yeah. Okay. This is the deck. This is the roof where the tennis courts are above this. This is the double basement. This is a sports complex for this international school. Change scenario demanding large spans. Once you get into, I did the school in 10 stages. I have done it up to the 10th stage, first to 10. So there were the low-rise buildings, high-rise buildings, large span buildings and all that. I'm just portraying this large span thing for you. Change scenario demanding large spans. As soon as you get large spans and weathering and things like that, you have to be careful about who the contractor is. Double this thing, centering, staging, centering, and all that. Here, of course, I can't do funicular shells and things like that because of the jointing and all that. So it had to be a monolithic. Advanced materials and technologies were imbibed in that. Handling the challenging situation, larger spans in both directions, and of heavier sections. These are very heavy sections in pre-stressed concrete. Large braced stagings result, high performance concrete, then manufacture handling of the particular casting and things like that, placement, scheduling of the work carefully, monitoring strength development, stressing with proper sequencing, releasing formwork precisely. a lot of things get involved in these large span things. So you have to have a good team, including the contractor for it. So you can see this is the swimming pool for the below in the sports complex. Post tension beams and slab with the spans of 25-40 meters in this portion, double story high. PT beams flared at ends to accommodate anchorages. One of the things we incorporated was to flare the ends so that the anchorages can be put properly, the quality of that. RCC College column 3 waffle slab, that was on this portion. Phase C construction having swimming pool, 4 tennis courts on precious concrete deck, 4 on one side, 2 on the other. So you had 2 modules. Now the taglines in this particular project was innovative large span, fiber reinforced, has been useful to develop a column-free congregation area during assembly requirement. One of the other things is the assemblies below, they wanted some more places in the sports complex for assemblies and things like that. So where you have stage and something hung from the top and all that sort of thing. Pile foundations are required. Geotechnical is a very important aspect for this thing, differential settlement. Pile foundations are required to reduce unequal settlement. Said to be first of its kind among many surrounding states. Then it's also, once you have designed or you're designing, you'll have to also try to find out what is the largest span done so far and who's done it and what they have got into, and just don't jump into the swimming pool and then try to swim. So that's what we also do.
Sir, I got one question.
Yeah, sure. Yeah.
There you have taken 2 columns.
There,
And,
yeah.
and this side only 1 column.
No, there's a lot of fun. Which side?
That's only 1 column, sir.
This one?
Yeah.
No, this one is in line with this column. This one is in line with this column.
Not 2 columns.
No. Yeah. Okay, that was that school. So you got a hang of large scale in that. Now the next one I did was a production building for one of the MNCs called Accei Kakinada production building. Now this production building had a hall, 60 feet by 40 feet, column free in one of the modules, and on top there was 12, I think, production building at 3 multiple floors, all of them with machinery. Was a heavy duty reactors of 12-ton capacity, each 7 in number in each floor. So you have that rotating machinery also in each of the floors on a column free hall. The column free hall is 60 feet by 40 feet for all the floors, having all high floors. Now what happened in this column free hall thing is, this client started asking that the columns be parallel to the walls, let them not project into the building and things like that, because it's a pharmaceutical company and things like that, clean rooms and what have you. I said, no, sorry. If you want that, it will be costlier, but we can do it for you. So then I went in for PT slab and we had to do that. So that also came in. Otherwise, we could have been projecting inside or outside. They all had high floors. Proposed precious concrete PT slab roofs for steadiness. Yeah, when you have rotating machinery of that sort, and then another thing they said was those rotating machinery can be changed. It's not fixed positions everywhere. So I said, give all the positions and you will have to mark it and put it on the board how the machinery should be installed. You can't just do anywhere and everywhere. If you want to, it will cost you 1.5 times. We'll do that. Let it float anywhere. Fuzzy logic. And they said, no, sir. We'll mark it on the floor and we'll follow what is this. You have to be tough. You can't tell the clients and they'll give you everything. So be careful. So, PT slab was proposed. Okay. Had to circumvent big quality and administration issues with concrete RMC. Now this is where you come in. You just put a PT slab or things like that, and then you specify And all the guys are so confident, overconfident. The RMC guys, they'll tell you, oh, we'll give you what we want, we'll give you and things like that. But you better check out, all the parameters of that. So we had the issues. Because overconfidence is also one of the things that you have to watch out for. RMC guys says, I've done project here, project there. The parameter of that project and the parameter of this project may not be the same. So what chemical do you use, what is the dosage and things like that, you have to go through it. Don't let them, because I just asked, we finalized everything. When the concrete came, I asked for the trip sheet. In the trip sheet, they are supposed to give you all the distinct proportions and the chemical and the dosage and all. There was nothing in that. Very reputed company, I don't want to name it. Then when I told the fellows, we are rejecting this contract. You can't give me a trip sheet like this. That fellow is calling his boss and saying, कोई इधर खड़ा है, वो पूछ रहा है, ट्रिप शीट नहीं है, proportion नहीं है, chemical क्या डाला नहीं है, मालूम नहीं ये क्या आदमी है ये. He didn't know I knew Hindi. Actually, I studied Hindi, so I told him, हमें मालूम नहीं, आपके पास है या नहीं, वो फोन दे दो, हम बात करेंगे. And that fellow was very apologetic. Sorry, sir. No, we should have sent it. I'm sorry. We'll send it right now. I said, till it comes, we are concrete will be studying here. You have to be tough. You can't just let them do what they like to do. What they do is that the concrete may be wanting to go somewhere. It will come to your place. And here you are, you're going 75, 85 feet. And the steel guys, listen the better. Of course, the steel guys, I must tell you about it. I told Mr. Sundarrao yesterday. The guys, 415 steel, they're giving me 418, 421. I don't know, I said, what nonsense? Why is this just lingering around 450? Then he said, why? Oh, ours is the best steel. We have supplied 45,000 tons to this university, 40 tons to 20,000 tons to somebody. What are you talking about our steel? Then I'm talking about your report. You have given your own testing reports. All of that are showing 415, 415. For 415, only 418, suppose it becomes to 400 or less. I want 10% more. This is large pack. Then the fellow said, I'm sure I'll give you 45,000 tons to that school. I said, did you find out what is the span in that? 26 meter gave you a span and the 8 meter span. And this is 85 feet and 75 feet. Then the client is saying he is my friend. I said, he may be your friend, but I'm seeing this deal. You got me. Okay. Manually?
Yes, sir. Manually.
Whichever way. If that is not possible, you can move it manually. So, would you believe that go with it? Go with this? It is stores building and last generation building. Okay. We had stores building also coming. I'll show you that photograph. It had 8 meters stacking, 8 to 10 meters traveling distinct trays, and it has going on rails. So it's fuzzy logic there. They can have all the loading in one, or they may not have loading in one, or they may have half the loading in one. They don't tell you all those things. They just tell you it is a stores complex. Then I said, you give me all what all you will do, what you will store in that. When you put a board, you paint the thing, not more than 1 ton per square meter here, 2 ton per square meter here, like that. So you have to be like that. It is post building, the same MNC company, heavy duty tall storage, industrial traveling collapsible racks of 8 to 10 meters height. Then I said, have you finalized the rack people? What is their depth? What is their width? What is their range? You got to work a lot on this particular. Fuzzy logic in what is movable loadings and in sustained loading. And we have made PT slab. So another thing is the PT also. Pre-stress. So then you take the fuzzy logic. Issue of rack foundation and damage schedules. Now here comes the thing. So we had said that we should have pile foundation for this particular thing. Then the client is telling pile is very costly. No, I don't want any pile fellows to come. They are very costly and things like that. I turned around and said it is 10% costly. I worked it out. So it is, you should have it for this. And there will be settlement problem. So settlement problem won't be there. No, doctor. We'll avoid price problems. So it's up to you. Okay, I'll put a wrap. I'll take them and put a wrap. I said, okay, please put a wrap, sir. We don't want 10% more. When they started digging it, they found all services going across in the building, all major services, power and things like that, all going through the building. Where would you put the wrap? For putting the wrap, you have to dig all those things. Our project got delayed for 3 months because those fellows, they don't want shutdown. No shutdown. You have to work without shutdown. Then you put wrap, you put support in between, put the deck on top, all sorts of things. Then it cost 10% more than 10%. It cost 20% more. And I said, if you had listened to me on Pile for Destiny, you would have had all these problems. This sort of thing keeps happening. Yeah. Next one. This is next one?
Yes, sir.
Yeah. So this rock foundation would have saved time and is working? Oh yeah. So when we had plant non-closure, service stable, existing issue affected immensely in the government. All the officers got fired by the management because of this. If they had listened to me and convinced those people for the 10%, we would have been much ahead of schedule and all that. They got unfortunate, very unfortunate that they all got fired. We were in the clear sort of thing. So all these experiences when you do video building, one of the things is also MNC, but be very careful, you can't put it in the emails, emails you travel to Canada and US, whatever you write, you can't say you did it, so it became like this. Keep your mouth shut and go with the flow. Okay. Yeah. Okay, that's the heavy duty thing, So we had put PT slab totally column free, in the particular thing. It was a big challenge because even the columns they didn't want it to project and all that, so we could do. But it was a big experience, although it was a very small project by that count. Now I finished that with the heavy loading in last time in here. This one is a space structure that we did. This is the one where we got into Limca precaution and all that. This is 300 feet column free. So I am just showing you the man standing here. This is the project manager who did it for me. The quality guy who stood up to me. He used to come to my office in the morning, take solutions for his problems, and go back in the evening. Next day, he will do the job. I salute those guys. And those 50 guys who worked on this project, imagine them. This particular thing, from here to there, this is about 5.5 or 6 meters, and from here it is 6.75 meters. These guys who did all the work on the top, they would have only 2 ladders, in our times. Everything would be costly. Open your mouth, contractor would say it's costly. I can't do this. This will cost much more. So you have to manage everything. The guys would have tea set in the rope from the bottom at 11 o'clock, so the fellows were working at the top. And they had only 2 ladders in 300 feet. So you used to climb the ladder from here and go to that spot. That fellow go from there and that spot. I said, these 50 people are the heroes. What am I doing? I am just these are the guys. And this project manager, 50 guys, called them and do that. And then they said they had 75 people. 25 people ran away, off and on. Things like that. If you do like this, he has to go to the toilet. He has to go back, come back down and go. Why don't you put 4 ladders? Why don't you do this? No go. But we did it. But this is in 1987, not in today's times.